Hello everyone, welcome back to another video. And today's video, I'm going to share about bubble sort algorithm. So actually, this video will be useful for the CSC graduate, undergraduate students. So let's jump into it. So before diving into details, we need to know about what is bubble sort. So it's actually the most simplest sorting algorithm, and how it works. It actually compares adjacent elements, and then it actually swaps between those adjacent elements if in wrong order, and then actually it repeats until sorted, and then it actually named after bubbles rising. So how it works, it actually, as I already mentioned, that it actually compare two adjacent elements, and and how it actually swap. It actually check if like the left element is greater than right. If it is true, then it actually put like the swap their position. If left element is greater than right, and its comparison starts from left to right. And then it actually move to next pair, and then it actually repeat until no swaps needed. And then after each pass, the largest unsorted element actually moves to its actually the correct position. So let's have an example here, like to visualize the how it actually works. So let's sort 52819. So you can see here, this is an unsorted number list. So on pass one, I mean this can be, you can say it is the iteration one. It actually finding the largest. So we would like to we are actually would like to sort it in on ascending order. I mean, from smallest to largest. So our goal is to largest number should be on right, and the smallest number should be on left. So let's finding the largest. So let's took these two pairs. I mean these two adjacent pairs from left. So it's like the two adjacent element is 5 and 2, and we are actually comparing whether 5 is greater than 2. Yes, then just swap it. So now we swap it, and 2 comes to the first positions, and 5 to the number position second. Then actually we need to compare 5 and 8, because the next adjacent elements is 5 and 8. And okay, then now the 5 is greater than 8. No, then no swap needed. And then the third adjacent element pair is 8 and 1. And then we compare 8 is greater than 1. Yes, then it actually we need to swap. So 8 goes to the position number, like 8 goes to here, and 1 should be so actually what I'd like to say that 8 should be go there, and 1 should be I mean 1 should be go here. So this is where it will actually solved. It will be solved. Then on the next, now we can see it's solved. And now we compare 8 with 9. So as 8 is not greater than 9, then no swap needed. So now you can see already 9 is on the top right, like is the 9 is the largest, and it's already in the correct place. Then yeah, so that is the first iteration. And then actually we need to continue the short until sorted. So now on pass 2 and 3, already 8 is in the correct place. And then we need to swap in 2 and 1. So we need to swap 1 and 2. And then it actually, we need to compare with 2 and 5. And do no swap needed, because 2 is less than 5, and so on. Now after just 4 iteration, the all the elements are sorted. So that is how actually the bubble sort works. So let's do some. Let me show you some coding, like how we can implement it on Python and JavaScript. So on Python, you can see we define a method called bubble sort, and we're like how many iteration we are actually running. The number of iteration will be the length of the array. So that is the number of iteration. So that is the first for loop, and on the second for loop, actually we are actually doing that adjacent pair checking and swapping if needed. So here you can see we define we call we like we took the number of iteration based on the array length, and on there are two for loop defined. One for loop is the control the number of iteration, and the second for loop actually compare the adjacent and perform the swap operations if needed. So here you can see we are always comparing the two adjacent element. I mean, let's say the element on index 0 and element of index 1, and if they greater than, then we just actually swapping. Otherwise nothing will be happen. So yeah, so I think this bit is simple. And here is an example on the JavaScript. So yeah, and now let's see about the time and space complexity, because this is actually important for the performance. So you need to always considering the time and space complexity of each sorting algorithm. So the best case, the time complexity will be big O n, and when it actually big O n actually already sorted with optimization. So nothing sorts needed as it's already sorted. But on an average case, the time complexity was big O n square, which is when it's the extremely random order. Like some are sorted, some are not sorted. And when it's worst, then it actually again big O n square, and when it's actually reverse sorted. And the space complexity is big O1 in place sorting as so the stable sort, yes, and preserves equal elements order. Well, so when to use actually bubble sort, that also you need to know. So for learning sorting concepts, the bubble sort is good, and for smallest data sets, I mean less than 50 elements, is pretty low. You can use bubble sort, and then nearly sorted arrays, or for teaching and interviews, you can just learn bubble sort or can use bubble sort. And when you don't need to use bubble sort, when you have large data sets and it's performance critical apps and complexity random data, so use quick sort or merge sort for large data sets. So I'll cover those sorts algorithms in the later videos. And well, so here is a summary, like the bubbles up, I mean largest to end, and compare and swap with adjacent pairs, and big O n square is the time complexity, and big O1 is the space complexity. So it's great for learning. It's actually simple and intuitive. So well, so on the next I'll show up the selection sort, which is another simple sorting algorithm. And thanks for watching. And now I hope you understand the bubble sort. So if you like this video, then please subscribe to the channel for more videos like this, and hope you'll be benefited. And well, so see you on this video. Then good luck. Bye bye.